I'm CK. Tonight we'll start a module from feedback modules. We've done a couple of theirs, I believe. I liked them pretty well. This is their LFO100. It's based on Japanese style 80s LFO. Looks like it has a lot of outputs and some interesting things you can do with them. So I'm looking forward to putting it together and hearing how it sounds in the rack. And I hope you enjoy the video. CK from the future. When I first did this module and started calibrating it, it wasn't oscillating at all. Went back and forth a couple of times with feedback modules, and apparently on the Rev1 board for main 1, one of the transistor outlines is incorrect. It's rotated 180 degrees, showing the flat spot going the wrong way, which of course screws up how the connections to the transistor are. You just flip around transistor Q5 and you'll be fine. I'll probably put this little video clip in twice, right after the intro and right before the demo, because I know some of you just jump right to the demo. But let me show you what it looks like on the board, and then I'll also put a picture up of what the revised board drawing would look like. So here, transistor Q5, the printing on the board shows the flat spot facing this way, facing down. It should be facing up. So these two transistors should have their flat sides facing each other. If you do that, everything will be fine and it'll work just great, as you'll see later. Here's the bag, again from feedback modules out of Romania. Picked this up from thonk.co.uk, as I do many of my modules. And look, I've done a couple of modules in a row that are a lot of surface mount pre-installed. Some, like the last one, took like 15 minutes to put together. This is substantial. This will be fun. Good. Back to a good complex DIY kit. Let's look at the front panel and the circuit board to start. Oh, look at this. Ah, come on. Let me get everything out first. Oops. We'll look at that in a second. Let's look at the front panel first. It's very light, composite, very light, not aluminum. Got frequency, high, low, mid-range, pulse width modification, fade time, and look at these outs we've got. And they're echoed down here too. Square wave, I'm not sure what the difference between those two are. Ramp up, ramp down, triangle wave, sine wave, step up, step down. So there's quite a bit going on here. And you can pull each wave out individually. And I think there's also the opportunity to sum. I don't know if that's sum or whether that's, there's a VCA in here which allows it to fade in and out. So that looks like a, I'm not sure what that is. And these two, bit 1 and bit 2, I'm not sure what those are either. But again, it looks like this is a lot of good stuff. So I'm going to make the assumption that these waves are all in sync. They'll all come out individually, but I believe they're all in sync with each other. I think this is the trigger, because it's got a trigger and an arrow pointing to that, so that, I'm not sure whether that's the clock in or whether it triggers something else, because there's CV in and there's reset. And we've got, looks like two clear plastic or translucent plastic windows that'll probably have LEDs behind them. And look here, we've got один, два, три. We've got 3 circuit boards. The control circuit board with the waveform selector rotary something, a pot for fade time, pot for free, switch for high, low, medium, second pot, then a bunch of jacks, then The switches are for... What does that switch do? I'm trying to line this up just right. So that switch... We'll figure that out as we go along, because I'm still not sure what bit 1 and bit 2 are meant to do. And the values are listed: 100K pot, 10K pot, 1 meg amp pot. And on the second board, the main board, as they style it, lots of resistors, bunch of caps, an op-amp here, an op-amp there, another op-amp, waveform adjustment trimmer pot, another op-amp, saw offset, another op-amp, and all the values are listed. That looks like it's 3904. I think that's a voltage regulator, but I will not swear to that. Again, all the values are listed, so we theoretically don't have to have a build guide. Then we've got level trimmer. This is the main version as 2 board, and a CD4024. I believe that's a counter chip, but I'll find out. Another op-amp, some capacitors, another op-amp, and random stuff in there. This looks like it's got, this is an M13700 chip. I'm not familiar with that. Then on the back here we've got frequency offset. It looks like a trimmer, but I don't see it. And then same here, maybe these are trimmers that go on the back of the board, because there are 2 caps on the back of the board, 3 caps on the back of the board. This is Rev 1 of the board. I don't see a date printed on here. They're all Rev 1. And then we still have in here, we've got 2 little things. I don't know what these things are. They're little squares, they're plated. We'll figure out what that is as we go along. I'm not going to lose them. I promise myself I'm not going to lose them. Let's see what else we got in here. This is, okay, they've got bags assorted. This is main 1 PCB. Bunch of 1/4 watt resistors. Bunch of trimmers. The caps, the transistors, because I think they are in fact transistors. I'm going to tuck this back in here as soon as I take a quick glance to see if anything too unusual is in there. It does not look that way. I want to put this back in here so I don't confuse myself. Main board 2, same thing, parts, bits and pieces. Power cord. All our chips. I'm actually going to look up the LM13700 right now while we're here. Oh, it's a dual transductance amplifier with linearizing diodes and buffers. So it's a fancy amp. Probably high fidelity for this thing. That's good. And we've got a bunch of pin headers and mechanical bits and pieces in here. All the sockets, LEDs. What does this say? Time bag. Time bag. Time.eu. That's the rotary selector to select the waveform we're going to be getting. So there's a bunch of mechanical bits in there, which here's all the jacks. Oh, the panel nuts are still on them. They didn't take the panel nuts off for me. Wham! A couple of 3 pots. Knobs are okay. The main knobs don't have any inserts, they're just push-ons. The rotary selector one does have a metal insert and a set screw so we can lock that in place, but the other ones are just so-so. So the main thing that I want to, as I said, we've got all the values on the board, so we don't technically need a build guide, even though I would like to know what the heck these things are. So I will be looking up the build guide and getting the soldering iron heated up, and we'll start putting this thing together. Looks like it's going to be a lot of fun. So we're going to do all the resistors first on the main. And now we'll put one on to see how much we have to, how tight against the board we have to be. Where did I put the bag? There it is. I keep the bag right next to the solder pad just so I remember what value I'm putting on. Just because sometimes you can get confused, or I can get confused. Okay, we can bend the legs pretty much right up against the resistor body. Maybe leave millimeter, half a millimeter aside. And we'll solder these and take a look at the, yep, solder wicked right through the board along the plated hole, which is always excellent. That's resistor time for today, and only two things to say. So on the board here, this and this position on main 2 are labeled as L, and L is typically an inductor. And there aren't two inductors in the package. There's only the one. Let me dig it out. There's only one inductor, and we also had two 10 ohm resistors, and there's no place on the board for two 10 ohm resistors. So I pulled up the schematic, and we'll see over here where the power connector is, which is right here. We'll see it comes into two diodes, and L1 and L2, which are not inductors, they're the 10 ohm resistors. So don't get confused by that. And again, that's the one component that is not labeled by value on the board. Though I will say we're also faced with this. It's got shape of a resistor, has no value listed, and the only thing I can figure is we want to put this inductor there. It comes off this 100 nanofarad decoupling cap from the CD4024, but the schematic at the CD4024 area here, where it shows the decoupling cap, does not show an inductor, even though you can see the trace from one side of the decoupling cap going to the this component, which I've got no other thought as to what it could be except this inductor goes in this spot. I'm going to drop them a note. I'm going to solder it in place as is, just because it feels like the right thing. When we get to that, actually I should just go ahead and do it now. If something acts funny, I can always pull it off. An inductor's not going to cause a big issue. Tape's coming off difficultly on this one. And yeah, there's no inductor symbol anywhere else on the schematic on this. I'm completely missing it, but I've gone over the schematic quite a bit looking for it, and I couldn't see it. So we'll just put that here, just because why not? What's the worst that can happen? The worst that can happen is it doesn't work. And if it doesn't work, I'll just clip that back out, and it'll probably work, because I don't expect it to cause an electrical problem. So we've got all that on the two boards. So I'm going to go back to main 1's board, and we'll do the diodes now. The Pots and Jacks board does not have any jacks. Does not have any resistors besides the two resistors that are already surface mount installed. And it looks like the main board 1 does not have any diodes on it. Oh no, it does. Where did I put that bag then? Oh my, what did I do? It's part of the problem when they give you so many little bags, you can get lost. They are all labeled, which is good, but I'm not seeing. I need a I need two 4148s, looks like, and I'm not seeing them. Oh, here they are. I had already set them aside in a different location. So we'll put these on. There's a black stripe on the body of the diode, and it goes to the white stripe on the circuit board. And again, now that we've talked about it a little bit, I'll just go into fast playback and I'll put them all on the board. We'll put the diodes on board 2. And that's all the diodes. Now the question is, do we put the sockets on now, or do we put the capacitors on? Because as you can see on the 13700 and both 13700s, the decoupling caps are inside the socket. So let me take a look at that part. Let's see where those are. Oh, they're in that mechanical bag. I want to see if I can put the I'm sorry, I'll finish that sentence in a second. I want to see if I can put the decoupling caps on after I've got the socket in place, because I would prefer to do that. And no, oh man, that's no good. I don't know if you can see it here, but this leg of the socket seems like it may interfere with that decoupling cap. Let me take a look at this one too. Yeah, it's still positioned pretty badly. Let me see what I can do here. I want to get the decoupling caps out for the main one board. There's 15 of them, looks like. They're all 104s. Yep. So if I take a 104 and I put it through the board, well, it doesn't interfere. Okay. So what that does mean is I probably couldn't drop it in there straight. So I'm going to put all the decoupling caps on before I put the sockets on. And then I'll put the sockets on. And then I'll go back and do the rest of the capacitors. I know it's kind of a funny way to approach this, but because of the way the decoupling caps, two of them are in the middle of a socket location, I want to get that out of the way first and then get the sockets on. I'll test fit that socket on there again. I'm sure it'll be fine, but yeah, it'll be fine. Now we'll do same thing on board 2. Put all its 100 nano, tenth of a micro decoupling caps on, and I'm going to do the same thing. I'm going to put the socket on while I'm putting the two caps inside of its perimeter. Okay, all the decoupling caps are on, so now I will go back to my standard process and put all the sockets on now. Now we'll put the rest of the capacitors on the boards. And since we've got relatively few components left on this board, I'm going to go ahead and put them on. And what I'm going to do first is look up this part number. And that's all the transistors, and you may notice up here that these two transistors, there are two leads that kind of bleed together, the holes are touching. They're supposed to, if you look at the schematic, that's the way they're supposed to go. Now I've got a couple of 100K trimmers. And that is all the electronical components on board 1. We've still got some pin headers to put on, of course. And by the way, that means I have to figure out how this thing stacks. Oh, I see how it stacks. Okay, I've figured out how it stacks, so that's good. But for now, that's board 1. I'll finish up board 2 after I feed the cats, because they're getting kind of noisy at the door. While we were off camera, I finished up the electronic components on main 2, and again, these marked L1 and L2 are actually the 10 ohm resistors. And I went ahead and threw the inductor in here because I can't see it causing a problem even if it doesn't go there. It's just going from the decoupling cap to ground, and adding an extra inductor shouldn't be a problem. Now I'm going to do the pin headers, because we're going to stack it like that and then like that. So we'll start with the bottom ones, and as you can see, I've already put the male pin headers inside the female pin headers, and we'll put them where they go. I'm putting the females on the bottom board, though that doesn't really matter. You could put the male ones on the bottom board if you want. Now, as to where they go, as you can see, there's 2 rows of holes on this middle board. Now, these holes have white outlines indicating that they're going to take the pin headers for the next level. So we want to get the pin headers from the bottom board into the unmarked holes, the unoutlined holes, even though they are outlined on the back side of the board, which makes sense, doesn't it? And there's that. Now we'll take these apart, like we took the others apart, because we've still got some things to do on the other boards. But they're ready to mate when it's time. And because we're all done with soldering on these 2 boards, we'll put all the integrated circuits on. And there's all the chips in place, and I'm visually double checking to make sure I've got the notches all lined up. Also on the main board, remember there are 2 071s. They're not all 072s, so be careful. The 071s go here and here. And I think that's it for these 2 boards. Oh, I got to put the power connector on here. That's what I have to do. Since it looks like we're done with soldering on these boards, because there are so many connections, I'm going to get my index card out and go along all the connections, make sure they're all soldered, make sure nothing is bridged or shorted, and make sure, again, primarily everything's soldered, because I have missed stuff in the past. Oh, that's those two that are... And that all looks good. So I am actually going to mate these two boards for permanent placement. Oh, I got to get my other mechanical stuff out to do that, because we've got spacers that'll go between these two boards. Like so, and put these, the next tier of spacers in. Now we'll do the pots and boards. I mean, pots and knobs and switches. Let's see what we got. Got two LEDs, ultras. There's the rotary selector for the waveform you want to use. There's a couple of 3 switches. They're all the same, I think. Oh no, one's a 3 position, the other 2 positions. So we'll make sure we get that right. And as I look at the instruction manual, I think that will go to the top. Yeah, high, low, mid range. Then we've got our Funkatron jacks, which I'll spend a minute or two taking the panel nuts off, and I'll speed the camera up while I'm doing that. Okay, that's the easy part. Now we'll get this rotary selector out. Come on, bag, open up. I'll put its panel nuts in that bin so I don't confuse myself. Let's see how this goes. Just double checking that. Well, I'm not sure which way it goes, and I'm also not sure if it really matters. One thing I do know is it's got a little indexing tab that I believe I will cut off. Let me get my carbide jawed cutters. Standard side cutters will work just probably fine for this, but I use my carbide tip just because they will never wear out. There, the tab is gone. I think, again, I'm not certain which way this goes. And again, I'm not sure if it matters. So we'll just, oh, I see. The support leg position defines where it goes. Okay. Because as you can see, this way the support leg goes in the hole, rotated around. The support leg does not reach the hole. It's about 1/8 of an inch, 2 or 3 millimeters off. So that will guide you on how this goes in. Still a little fussy. There we go. Click that in on both sides. Give that a little push. There we go. It'll rotate just fine. I'll get the other potentiometers. I always put the potentiometers on first before the jacks, because the potentiometers, the support leg, the little jag in there, makes them click a little bit and jiggle the board a little bit as you put them in. And if you have the pots already set in place, they don't have any locking legs, so they tend to bounce out. And then you got to put them back in again, and you're all sad because you're doing it twice. I just thought of something I was going to do, but completely forgot what it was. And I put, of course, I put the these will set here. These set the ramp, the steps on the ramp. If you have everything up, 16 steps, 8 steps, 4 steps, intercalated steps. We'll look at that on the scope when we get this running, so you can see what they're talking about there. And this is the frequency range switch, and it goes from low, which is 0.07 hertz, 14 seconds, to 1 hertz, medium, 0.3 hertz, 3 seconds, to 4 hertz. Then high is 3 hertz to 33 hertz, which is pretty nice. You also can control it with CV in. Now we'll set all the jacks in place. There's all the jacks. Normally you have to keep the jacks from popping out constantly. These were a real struggle to just get in. Now let me find those LEDs. Now we do have, see right here, we've got 2 slots that looks like that's where the these mystery bits go. Oh, I see. I guess I see. I think what these are, let me put the soldering iron down. I think what these are is they're light deflectors. Oh. Okay. I did not envision that. So we're going to have to take the panel off a little bit. I think I may be able to just pull it back on this end to do that. Let me get a pair of tweezers. Yeah. So that's where those go. Mystery finally solved. All the back connections are made, and off camera I put all the panel nuts on because I didn't figure anybody wanted to watch that. If you do want to watch that, if you want me to record everything and have it maybe as a separate video even, just let me know. Now I'm fitting the stack together. So that's the front, the side, the back, the other side, the top, and the bottom with their little LED light baffles. So let's put it in the rack and get it to oscillating. CK from the future. When I first did this module and started calibrating it, it wasn't oscillating at all. Went back and forth a couple of times with feedback modules, and apparently on the Rev1 board for main 1, one of the transistor outlines is incorrect. It's rotated 180 degrees, showing the flat spot going the wrong way, which of course screws up how the connections to the transistor are. You just flip around transistor Q5 and you'll be fine. I'll probably put this little video clip in twice, right after the intro and right before the demo, because I know some of you just jump right to the demo. But let me show you what it looks like on the board, and then I'll also put a picture up of what the revised board drawing would look like. So here, transistor Q5, the printing on the board shows the flat spot facing this way, facing down. It should be facing up. So these two transistors should have their flat sides facing each other. If you do that, everything will be fine and it'll work just great, as you'll see later. Now we're going to do some simple calibrations on this. The calibration instructions are not available online yet. I wrote to feedback modules and they sent me what they have so far. I will paste it in the description of this video if I remember. If I don't remember, please somebody leave a comment saying you forgot again, and then I'll put them up. I'm sure he'll get them up soon, but it's not up right now. So there, we're going to start by center jack and saw, trim wave adjust until you have a perfect saw wave output. Not quite perfect right now. There's a little bump. See that little bump? Let me get my pointy thing. There's a little bump right there. Right there. Let me see if wave adjust will change that bump for me. I'm going to increase the frequency so I get a better, faster trace. Looks like it's going away. See there, it's going away. Good. I hope I'm not getting my head in the shot, but it's looking pretty good now. Good. So that worked. I'm going to get up and do fixed focus on the scope camera just to make sure it doesn't drift along. Okay, so that is a pretty straight line. That little hump that was in there went away, and I'm pretty comfortable with that. Oops, my iPad went black. Now, we're going to trim the saw offset until the saw waveform is exactly above the zero line of the oscilloscope. And I think looks like I'm a little low on that. Just barely enough to notice. I don't know if I would notice, but I'll take it up there. Now it's right on the line I want it to be on. Okay, so that's good. Pay attention, I have clipping of the waveform up or down, and the waveform is not clipped. Check the triangle level and the triangle output. And 9.3, he says should be about 9.3 volts, and I'm getting 9.6. And now I'll move it over to the main output and move to triangle. Where's triangle? There it is. And that's looking pretty good. So it's not actually, the other one was 9.6 and this is 6.0, so I'm going to adjust VR1, the level trimmer. Where is it? There it is. To get that about 9.6. Peak to peak. It's 7. 7.6. 7.8. I'm going to slow this down a little bit. I'm sorry. 9.2. So I'm going to go to match the 9.6 just because I feel like it. Because that's still below 10 volts, so I'm not worried about it. And I do want them to match. Okay, that's 9.6. So the try from the individual jack to the mix output jack, and you notice you'll see that it's red when it's negative, green when it's positive on the LED next to the jack. Can you see that? Yes, you can. Good. Okay, so we got that. Adjust VR1 same amplitude. Did that. Probe the square output. Switch frequency to high and turn the frequency knob to maximum. So this is the square. And what do we want to do again? Frequency to high. I can barely see that on the scope. Frequency knob to maximum. Frequency counter. The counter on the scope is saying this is 46, and he would like it to be about 30 hertz, or kilohertz, or 30 hertz. Where's frequency adjust? VR2's frequency adjust, okay. Going the wrong way, now I'm going the right way. Let me take this out of roll. Put it back in roll. Okay. Forty-five, 44, 43, 42, 40, 38, 37, 36, 35, 34, 33, 32, 31. Slow down a little bit. He would like it to be at 30, but the lowest I'm able to get it here is 30.39. That's fine. Peak to peak is 9.2 volts. That's okay. I decided not to put this in the rack. I'll just do it on the benchtop because, I mean, in the rack it's just going to make some modifications or something or other, and I'm not going to muss around with that. So there is the pulse. Here's this pulse, and I'll change pulse width. And as you can see, the gap between pulses is getting longer, and the pulses themselves are getting very short there. There, bring it back a little bit, bring it back a little bit. So that works fine, and we're coming from the main out. I'm going to go swap over to this pulse out and see what that looks like. Get my head in the shot for a second. Not doing what I thought, but let's see. Do sine wave, looks dandy. Saw wave, looks dandy. Let's change the frequency a little bit. Let me go to high, and there we go. That's very high. Then we'll go to the bit ladders. Here's one bit ladder. See, that's a little squarer. I mean longer. Switch the switches all around. You can get all kinds of laddering. Let's go the other way on the laddering. Looks dandy. Now I don't know what this out is for. I guess that just replicates the other out. Okay, there's the ramp going one way. Actually, that's the wrong way. Sticking my head in the shot again. Let me lower the frequency a little bit. Huh. It's like those are reversed. That's interesting. Then a saw wave, sine wave, and then the step function thingy again. Now I'm going to try, let me go to this and turn fade time all the way up. Maybe I have to go to out for that. Maybe I'm misunderstanding what it does, which is certainly a possibility. Well, I don't know what it does, so I'm not helping you by showing you that. But that's what it does. Sends out a bunch of good waves all at once, so you can have, oops, I went into CBN. So you can have whatever wave combination you want. Let's go to very high again, and we'll watch this sine wave just go all compressed and crazy. So that's what it does, as you saw. It's not a simple build. There's a lot of parts that go in it, and you do have to remember, if you have the version 1 board, that you have to reverse that transistor. If you don't know what I'm talking about because you just jumped to the demo part, I've got a chapter marker in 2 places where I talk about having to reverse one of the transistors in the first board set that went out. He's going to be fixing that, but it'll be a little while till those new fixed boards hit the market. Another good one from Feedback Modules, and I hope you enjoyed the video.